This is our third daily quest this week. Once again, reminding you that we have a Friday, October 12th quiz coming up that will be covering all of the content that has been showing up on the daily quest for the last 2 weeks. Once again, our first problem is asking us to find 3 equivalent fractions to 1 1/2. In this problem, once again, I want to remind you that if you note that 1 1/2 is equivalent to 1 1/2, the first fraction should be just drawing the picture. Then for fractions 2 and 3, we need to change 1 1/2 into a fraction that is equivalent, which means it has the same amount of shading. Well, when we're dealing with the whole numbers, the whole number is going to stay as 1. Then a half, we need to find something that is equivalent to 1/2. I'm going to multiply the numerator and denominator by 2 to create 2/4. 1 2/4 means I leave the whole number the same, and I cut up the half into 2 equal pieces to create 2/4. We can do that process again. In fact, by multiplying the numerator and denominator by 2 here, we can actually create 1 4/8. Whoops, there we go. 1 4/8. We're going to try that again. 1 4/8. There we go. So then, for our picture, we have our halves, and we need to cut them into 4 equal parts, because 1 times 4 is equal to 4. So I cut up here and here, and I cut up each of these pieces, and I now have created 4/8. There are 3 equivalent fractions. Let's go to problem 2. We have subtracting 3/4 minus 2/3 using both the traditional algorithm and drawing a picture. For the last few mini quizzes, or the daily quests, I have been doing the algorithm first. A good common denominator between fourths and thirds is 12ths, because 4 times 3 is 12. Now I need to get the pen here. Here we go. 12ths minus 12ths. So I can create 12ths by multiplying both of these numbers times 3, and I can create 12ths by multiplying both of these numbers by 4. 3 times 3 is 9. So we have 9/12 is equal to 3/4. 2 times 4 is 8. So 2/3 is equal to 8/12. 9/12 minus 8/12 is going to be equal to 1/12, which already is in simplest form. So we are done. Now we have to draw the picture to match. Since we're doing subtraction, we draw the first fraction, which is going to be 9/12. So I'm going to start with 3/4 right here. So there's 1/4, 2/4, and 3/4. And I have to change 3/4 into 9/12 by cutting every box into 3 equal parts, because that's what we multiplied the numerator and denominator by. And I have to get my line button here. There we go. So 3 equal parts, 3 equal parts, 3 equal parts, and 3 equal parts. And now I have 9/12, and I need to take away 8/12. So I'm going to erase. There we go. My eraser doesn't like doing this. There we go. Take away 1/12, 2/12, 3/12, 4/12, 5/12, 6/12, 7/12, and 8/12. And some people just like Xing out instead of erasing, but erasing's just fine. So I now have 1/12 left. My answers match, and I am done with this problem. Let's move to the next one. So what I have here is I have 3 divided by 1/3. And in order to do this problem, I have to make sure that I understand what this problem is actually asking me to do. 3 wholes cut up, and this is where it's hard, cut up into equal thirds. So what it's really asking is how many 1/3 fit in 3 wholes. So what I'm going to do is I'm going to take this problem and I'm going to cut my fractions up into equal thirds. Whoops, let me try that again. So I have my thirds here, and it wants to know how many 1/3 fit into 3 wholes. Well, I have 1/3 here, I have another third here, I have another third here, I have another third here, 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 and here. And so I would have 9 total 1/3 fit in 3 wholes. There we go. 9 total 1/3. So the algorithm here is a little bit tricky, and we have to remember something that we learned last year, which is when you are dividing fractions, the 3 terms are keep, oh my lord, come on, so there we go, keep, change, there we go, and flip. Keep, change, flip. So we keep the first fraction. In this case, it'd be 3/1. We change division into multiplication, and we flip the next fraction into 3/1. So we have 3/1 times 3/1, which is 9 wholes, which is equal to 9 total, which is the answer we got on both parts of our problem. Let's do one more. So for this problem, we have 8 times a fourth. And we've been doing the fraction boxes method before. This time we're going to try the groups of. And I always try the groups of method when the whole number gets pretty big. And 8 is starting to get pretty big. So what I want to do here is I want to draw 8 total fractions. And I can draw them as circles, you can draw them as squares, you can draw them as whatever you want. And it wants to know that there are 4 total groups. There we go. And it wants to take one of 4 total. So I need to cut these up into 4 equal groups. And we got to figure out how much is in each group. So if I made this is one group, this is another group, this is another group, and this is our 4th group. Each group has 2 wholes in it. One of the 4 groups, I can pick any of them. Let's pick this one. Means that there are 2 total. So a 4th of 8 is equal to 2. Because we had 4 total groups, one of the 4 groups is equal to 2. The algorithm, we need to turn them both into fractions. 8 turns into 8 wholes. 1/4 can stay. 8 times 1 is 8. 1 times 4 is 4. 8 divided by 4 is equal to 2. And now our answers match on both of these problems. As always, if you have any questions, please let me know.